Hi, my name is Daryl Olive, and today I'll be talking about e-learning theory, also known as multimedia learning. What's wrong here in this picture? Well, you see a gentleman here who is doing a training for his job, and he is reviewing 108 PowerPoint slides. Now, some of you may know this as death by PowerPoint because the presenter is simply reading from the slides. So what is e-learning? As defined by Richard Mayer, one of the leading theorists in the area, it's training delivered on a digital device, such as a smartphone, a laptop computer, that is designed to support individual learning, or in this case, with the gentleman, organizational performance goals. In my opinion, it's not only about platforms to deliver learning, but it's also about how instruction can be more effective when it's designed according to how our brains actually work. So there are two main theories behind e-learning. One is the information processing theory, and the other is the cognitive load theory. The information processing theory was developed by George Miller, a leading psychologist at the Harvard University, and he's also known as the father of cognitive psychology. His work in the 1950s really focused on understanding and coming to the conclusion that the human brain has a limited working memory or limited capacity in this function. He basically came up with the magical 7, and that's the idea that our brain plus or minus 2 could really functionally manage 7 items. For some people that's 5 and others 9. Cognitive load theory, including Richard Mayer and John Sweller, really looked at how the combination of visual input, auditory input, or what we call sensory input led to processing, and that processing can lead to long-term memory or active learning. So looking at the theory in more detail, you see here that one of the core assumptions of the cognitive load theory is that there is sensory information, and that sensory information comes through two separate channels, one for processing auditory information and one for visual information. In order for us to process that information, we actually select that information, what we decide that we want to use in our working memory. So there's a certain amount of attention involved, or executive function, and it's really important in this stage to simply get someone's attention. Now, George Miller, as I mentioned earlier, really focused on the limited capacity of the working memory. He put that capacity as up to no more than 30 seconds and focused on that working memory only being able to process about 7 bits of information. Now, he also noticed that that information could be actively processed and stored, especially when in the forms of chunks. Now, when we take that information and process it, we integrate it with prior knowledge, and that's what is actually stored in our long-term memory, which has no capacity. Now, with time, with rehearsal, information can actually become automated, just like brushing your teeth or learning to ride a bike. Over time, you can easily retrieve how to do that without very much thought into the process. Now, this slide here really just goes through the idea of cognitive load. Let's define cognitive load. It's really the amount of working memory required to capture and analyze information and store it into that long-term memory. It has 3 components. One is intrinsic load, and this is based upon really the natural complexity of the information or subject matter that you're looking at. The second one is extraneous load. This is caused by high levels of interactivity due to poor instructional design. And then finally, germane load. This is actually material that helps effectively store information into that long-term working memory or beyond that long-term working memory, and it's stored in organizational folders or a filing system called schemas. So the goal with load is to overall reduce the total cognitive load, going back to that principle of having limited capacity. So we try to manage our intrinsic load. We try to minimize anything extra that makes that information more difficult to process. And we try to maximize the things that help us effectively put that into our long-term memory. So some of the key principles of cognitive load, Richard Mayer, one of the theorists behind this, described e-learning or multimedia principles and describes several important factors. One is the concept of multimedia, and that's simply learning that overuse of text actually decreases the ability to absorb information. So using graphics is much better than using text alone. Also, it's best when you align words to graphics when you're presenting information. Presenting words as audio narration is much better than presenting text on the screen. When we explain using audio narration along with visuals, it's then redundant to use on-screen text on top of narration and visuals. Learning is also better when graphics and text are aligned next to each other. It's important to be personal in the presentation, so using a conversational style, using inclusive language, and really presenting material that is of interest to the audience. Richard Mayer also found out that it's much better to break down the material into bite-sized segments, so going from very simple components to complex. Pre-training is the concept that you teach people who are novice learners information about key concepts, definitions, prior to teaching the whole complex cycle of information. And then finally, practice. Practice makes perfect. So in this context, it's important to practice and rehearse information, and that helps put it into long-term memory. So these are some e-learning practical tips for teachers. One, it's important to provide a background of information for your learners. This is especially true for novice learners. Here are some e-learning practical tips. Novice learners should be supplemented with background material on the subject matter, which helps contribute to schema organization. Examples might include detailed handouts, outlines, list of definitions, and more text and learning materials that are going to be used for out-of-class review. Using worked examples is another important key. A worked example is a problem that has been solved for the learner with every step fully explained and clearly shown. This is often done in mathematics. Research shows novice learners who are given worked examples actually learn better and perform better when retrieving information for the future and doing related tasks. It's also important to know your audience because worked examples and background learning can actually be counterproductive for those beyond the novice stage, and it could be quite frankly boring and not interesting. Simplifying your presentation material really helps, especially with complex topics. Less is actually more. Some things you can do is reduce heavy text material, utilize narrative and visuals when presenting, chunk or segment information for easy organization into schemas, as well as chunking that information for later views. So if a student doesn't understand one particular portion of the subject matter, they can go back and review that particular portion. It's important to reduce information loss. Scheduling assignments and activities close to the period in which new information was introduced actually promotes adequate rehearsal, retrieval, and storage of that information into long-term memory. Collaborative assignments help gather cognitive resources from multiple people, and so thereby you're effectively increasing your work capacity and decreasing that cognitive load. Finally, it's important to connect to the audience, grab their attention, make it emotional, maybe tell a personal story, use news, or any information relevant to your audience. You can also make the language inclusive by using I, we, and us.